Hi, everyone. How are you all doing? Thank you so much for joining us today. I am Harshita Rajshekara, Chair of GovHack. I'm super excited to learn all about artificial intelligence and machine learning. Before we start, I would like to do acknowledgement of country. GovHack Australia acknowledges the traditional custodians of the various lands from where all of us you are watching, and all Aboriginal and Torres Strait Islander people participating in GovHack. I pay my respects to the Karuna Mayuna people from where I am live streaming to you this evening. GovHack pays our respects to elders past and present and celebrate the diversity of Aboriginal and Torres Strait Islander people and their ongoing cultures and connections to the lands and waters of Australia. Ladies and gentlemen, distinguished guests, and fellow technology enthusiasts, it is both an honor and privilege to welcome Bobby here today. Hailing from the vibrant city of Sydney, Australia, Bobby brings to this stage a passion for driving change and relentless curiosity for the ever-evolving landscape of technology. As a solution architect at AWS, Bobby's journey has been one of exploration, experimentation, and collaboration. With a specialization in fostering digital innovation within the public sector, Bobby had the incredible opportunity to work alongside visionary organizations and addressing intricate challenges that demand integration of cutting-edge technologies. Bobby's academic foundation in software engineering, carefully cultivated at the esteemed University of Canberra, has provided Bobby with the tools to prototype, engineer, and construct solutions that push the boundaries of what is achievable. From Bobby's early days in systems and infrastructure administration came his immersion in artificial intelligence and data area. Bobby's diverse technological background has equipped him holistically perspective on crafting resilient and transformative solutions. Today, Bobby is going to talk about data analytics briefly today and also talk about AI tools that are available from AWS. Please feel free to add your questions in the YouTube comment section and Jason will help us to get them to us. Especially GovHack participants, please make sure that you leverage this session, considering we need to be agile throughout the weekend. So we need to make sure that we make use of artificial intelligence tools as much as possible. So without further ado, please put your hands together to welcome Bobby from AWS. Please welcome Bobby Kohbor.
Thank you. Good to be with you folks again, where we cover a bit more of a deeper topic around data analytics and AI/ML on AWS. One thing I really want to focus on here, similar to the last session, is that I want to be able to provide an understanding of capabilities that I think would be most beneficial to you over the hackathon weekend. So I will be jumping around a bit between some of the services and capabilities. We're obviously not going to cover every topic or every service under the data analytics and AI/ML banner because we'll be here forever. What I will look to do is try and make this as relevant to what you may need as possible. If you are joining and you weren't present at the previous session, and you are looking at trying out some of these services on AWS or potentially using the platform for the hackathon weekend, please feel free to message me on Slack, on the GovHack Slack workspace, and I can provision some credits for you to get started so that you can leverage the platform and experiment without necessarily having to use your own money. Okay, So getting into it, this is what the agenda looks like for what we're going to be talking about. We're going to start with analytics on AWS. We're going to touch on storage, ingestion, transformation, and visualization. So some of the aspects of analytics that you will probably need to embark on as part of the weekend. We'll then move, or at least that will provide a good segue into AI ML on AWS. So potentially utilizing some of that data to be able to build intelligent insights or intelligent capabilities in your offering or application using potentially managed machine learning services, which don't necessarily require a background or like a data science background, for instance. We'll also discuss SageMaker for those who want more of an end-to-end traditional machine learning experience. So talking about analytics, now there's quite a few different areas in the data storage space when it comes to things like analytics. We have a number of different types of data storage platforms, such as relational. If you're familiar with MySQL or MariaDB, these would be considered relational databases. We're all quite familiar with those. Key value document store for being able to have high throughput, low latency reads and writes, or to be able to store documents quickly. All the way through to graph databases, being able to understand relationships between our data, time series ledger, such as blockchain. So there's lots of different types of data stores. And in AWS, we have lots of different services to be able to cater for those data stores. As I mentioned in the previous session, we have Amazon RDS, our relational database service, to be able to quickly provision capabilities or engines such as MySQL or MariaDB, Postgres. Most of the common relational database engines can be provisioned out of the box with a single click on Amazon RDS. Additionally, if you are interested in a key value store or even a document store, Amazon DynamoDB might be a good option there as well. It's quite easy and quick to get started with and can provide a great capability for any high traffic web apps or e-commerce type systems. There's obviously a number of other capabilities that you can see on this slide here that AWS provides in relation to those database types. I won't go into them today. However, they are worth taking a look at if that's something that you're interested in. But another form of data storage that I did want to touch on, because I do think it's quite relevant to the hackathon, is potentially storing data within a data lake. So what this allows is for you to essentially be able to take any data in any form and place it in a central location, whether that's tabular data, structured or unstructured data, maybe binary data, so images, for instance, or audio, being able to store all of that in a common location, and then being able to build a catalog of that data that sits in that common location, and then being able to lay out other services on top of that to be able to utilize that data. So for instance, if we've got tabular information coming in CSV or Parquet form and landing that in our data lake, we can build a catalog over that and then utilize that for our machine learning training. Or maybe we want to build some graphics over the top. Maybe we want to build some interactive graphs. We can do that as well. Some of the good things about utilizing a data lake is the fact that it accepts all types of data. It's pretty much infinitely scalable. It decouples the storage and compute, so you can expand that storage footprint without having to expand the compute footprint. The compute is usually what costs a fair bit of money. So being able to decouple those and only use compute as needed can be quite handy. And probably one of my favorite aspects is the fact that it's schema on read. So if you're using a traditional database, traditional relational database, you often need to dictate that schema in the form of tables, columns, data types, that sort of thing. With a data lake, you can just simply dump all the data into that location and determine what the schema looks like on first read. This is what the life cycle looks like when you are looking at a data lake type of operation. We're obviously not going to touch on every service on this slide today, but it gives you a bit of an idea where we've got Amazon S3 as our central storage platform for our data lake. On the bottom left-hand corner, we do have some ingestion mechanisms, which we'll touch on a bit later on. Once that data is ingested, we can then use AWS Glue in the top left-hand corner to be able to catalog that data, maybe be able to transform it. And then in the right-hand corner, we've got analytics and serving. So being able to apply either searches or visualizations to our data to be able to provide that to our end users. So our data lake acts as that central storage platform that is able to facilitate all of this. As I mentioned in the previous session, Amazon S3 provides a web accessible object store that's accessible through API and HTTPS. It is effectively infinite in scale, and it does, there's that actual change in that storage, in that price. Before I had it as US East 1. This is properly appended for AP Southeast 2. So storage within the Sydney region within an S3 bucket is 2.5 cents per gig. So when you are dropping data into your Amazon S3 location, depending on the data type, if it is tabular data or effectively structured data, you would be looking at dropping it into there as a CSV or Parquet file or JSON file. This gives you a bit of an idea of the number of different ways to be able to ingest data into a data lake. A lot of these methods you probably wouldn't necessarily be using over the hackathon weekend. Things like using the database migration service or using a data sync agent to be able to sync the files to Amazon S3. What you might be potentially utilizing is the streams capability. So you might be looking to ingest data from a live stream. You could potentially do this in effectively in a 5-minute batch process in Lambda. You could be pulling data from that stream, putting it into a service called Kinesis Data Firehose, which effectively consolidates a lot of that data over a specific period of time and pushes it to Amazon S3 as a data format such as S3 or Parquet. To be honest, if you are looking at just grabbing a data bundle, so maybe you're getting access to maybe a zip file with a bunch of CSVs in there that you need to inspect or analyze, maybe that's 100 megs worth of data. It's probably easier just to download that to your laptop and then upload or to your system and then upload that to Amazon S3 than try and write scripts to move it from one location to another. And that gives you the opportunity to potentially use Panda or another module or SDK to be able to interrogate and transform that data as needed before moving it to Amazon S3. If you are looking at exploring the data that you've received, maybe you're looking to understand what that data contains, you can use a service in AWS called AWS Glue-Data What this allows you to do is connect to data sources, whether that's in Amazon S3 or even in Amazon RDS. You can leverage built-in transformations to transform that data. You can potentially profile that data. So maybe you need to understand with a specific column, whether the mins and maxes or the means of that column. And the good thing about this service is that it's really for users of all technical levels. It has a visual interaction capability. You don't have to write any code. You can simply use the GUI to be able to navigate your data, be able to understand it, and potentially transform it and export it into the form that you need. The other option, if you're looking to transform your data to be able to understand and transform it, is to potentially use AWS Glue's ETL capability, or extract, transform, and load. If you are familiar with PySpark, or you're familiar with Apache Spark rather, this is a serverless Apache Spark environment that allows you to transform your code, transform your data using code that you write, PySpark code that you write, and being able to transform that over multiple nodes. So if you've got, let's say, 100 gigs worth of data, you're probably going to need something heavy duty like Apache Spark to be able to process that data. AWS Glue is able to help you there. Additionally, AWS Glue provides a cataloging capability. So if you're dumping a load of data into S3 and you need to be able to understand what that data looks like from a tabular perspective, you can run a AWS Glue crawler, which will crawl through your data, understand the tables and columns and data types, and then populate what's called an AWS Glue data catalog that describes your data so that you're able to then write queries against it. When we're talking about running queries against your data, specifically the data in place, you can use something called Amazon Athena. This is effectively a Presto engine, I believe, under the hood. It allows you to be able to run standard SQL queries against your data that sits in S3, whether that sits in Parquet format or CSV or JSON. You don't need to move your data to a relational database service, such as MySQL. Traditionally, a lot of people would move their CSVs into a relational database service to run standard SQL against it, to be able to explore that data. That's not necessary here. You can use Amazon Athena to run those standard SQL queries against the data that sits in Amazon S3 and be able to gain insights straight away. And then finally, Amazon QuickSight. So this is a business intelligence tool that allows you to generate interactive graphing capabilities that can tell a story about your data. So whether that's a bar chart, line graph, it is effectively serverless, so you don't need to deploy anything to be able to get started with it. You just need to sign up within the AWS console, point it at your data, whether that's in a relational database service or whether that's in S3, and then be able to start configuring your graphs. It does have natural language capabilities as well, so you can potentially leverage the feature within QuickSight that allows users to ask questions of your data in a natural language, and it will present the information to them in visual form. So moving on to AI ML. Now, once again, similar to a lot of other AWS services and capabilities, it is quite a broad portfolio of services and capabilities that can be a bit overwhelming for those who are potentially getting started with AWS. The way that I like to think about the AWS AI ML stack is to break it into 3 different groups. The first one are our AI services. These provide you the ability to leverage intelligent capabilities in your application or service without necessarily having to know or understand machine learning. So you don't need to be a data scientist to leverage these capabilities. As long as you can use the SDK, you can invoke an API, you would be able to use these services out of the box. They're effectively pre-trained and hosted machine learning models. The next one is Amazon SageMaker. This does have some no-code machine learning capabilities for business analysts. However, it does provide an integrated development environment that allows data scientists to be able to go end-to-end when it comes to prepping data, training models, deploying models, and managing them in production. And then the final one is machine learning frameworks and infrastructure. So these are for folks who don't necessarily want to leverage the SageMaker or the SageMaker Studio ecosystem or the IDE. Maybe They just want the infrastructure. So maybe they just want the NVIDIA GPUs attached to a virtual machine, and off they go. They've got their own scripts. They've got their own frameworks. They can leverage that bottom tier. So really dependent on where you are in your machine learning journey, there are services and capabilities that you can use. Now, I do want to give you a bit of an understanding of some of the more managed machine learning capabilities, because I do feel like out of the box, they're the quickest to get started with, and in your hackathon weekend, they'll probably make the most sense to leverage as part of your journey. So the first one is around Amazon Recognition, Image and Video. Being able to leverage a managed computer vision service. So you're able to provide an imagery in the form of either a static image or video, and it is able to provide you information and context about that image. Things like what objects are in the image, or the scene, or the activity, any text that is in the image. So maybe you need to use OCR, optical character recognition, to be able to get information from that image. PPE detection, face detection analysis. Is the person happy or sad? All of this can be leveraged using Amazon Recognition's capability. All you need to do is provide it the image that you need an analysis on, and it will return essentially a JSON payload with information as to what's in the image, as well as its confidence scores. One other thing you can do with Amazon Recognition, obviously it's a generalized computer vision model. If you need it to have a specific business context, so let's say that you work in manufacturing, you need it to understand the difference between different types of bearings, which can be quite industry specific. You can easily train Amazon Recognition using custom labels to recognize those specific, those domain-specific products. It makes it quite easy to be able to do that through effectively being able to annotate images, be able to submit that to the machine learning model and train it. It makes it quite easy to be able to build custom capability into the computer vision system. Another capability that is provided as a managed service is Amazon Comprehend. This provides you the ability to discover insights and relationship in text. So that text can be in the form of any document, whether that's email or chat or so forth. It can be, a 100-page document. It can be pushed into the Amazon Comprehend service that automatically extracts insights from that text. Things like it can potentially identify personally identifiable information, or it can determine the sentiment of that document. It can find topics or entities in that document, all sorts of things. So it can certainly make it a lot easier to understand and be able to build an understanding of that document. Amazon TextRact provides the ability to extract text that may be handwritten, for instance. So if you've got photos of handwritten documents, maybe you need to digitize those documents and be able to pull information from them in a programmatic manner. Amazon TextRact will be able to digitize those documents. So it will be able to use optical character recognition to be able to pull the text from there. It'll be able to detect things like key value pairs or even tables. One thing to note here is that you can actually chain some of these capabilities together. So you can potentially have a handwritten document that has its information extracted using Amazon TextRact, it's digitized, and then that goes into Amazon Comprehend, where we're able to inspect that document for key information. Amazon Personalize is a capability very similar to what Amazon.com provide. If you're ever searching online for a product and it recommends another product to you, that could be based on your purchase history. It could be based on the fact that you looked at a product similar to another product that someone looked at. They looked at a different product, therefore the recommendation engine recommends that product to you. So this sort of machine learning capability can now be accessed by yourselves. You just need to bring your training data set. doesn't necessarily need to be around e-commerce. It can be around recommendations of other sorts of services or capabilities. So certainly Amazon Personalize may be something that you might look to use. Amazon Forecast, being able to effectively predict the future or crystal ball things that you have potential data on. So maybe that's to do with the weather. Maybe that's to do with things like in a hospital or clinical session, being a clinical environment, being able to determine when you next need to reorder certain bits of stock, whether that's PPE, that would have been highly relevant during COVID, for instance. So being able to look at a data set and be able to identify trends in that data set to be able to potentially predict the future, 1 or 2 months out from now, for instance. Look out for metrics. So this is another service that allows you to find anomalies in metrics of any in a lot of different services, or even in data that sits in S3. So if you've got information coming into S3, maybe you're polling a data source, you're pulling that information, putting it into S3. Maybe you need to look for anomalies in that information. Maybe it's building data that's showcasing or tracking the temperature of a building. Maybe one of the rooms, the temperature starts to escalate quite quickly. Amazon Lookout for Metrics is able to keep an eye on that information and look for anomalous detail that it can then action. So on the right-hand side, you can see that it can send the results to potentially a Slack room, or a Slack channel. It can send those results to AWS Lambda or Amazon SNS, so that it can potentially invoke a external service or take some sort of programmatic action. Amazon Kendra is a intelligent search capability. So if you've got a bunch of documents, or maybe you've got frequently asked questions that you want people to be able to search through, Amazon Kendra provides that intelligent search capability where people are able to ask natural language queries of it, and it's able to search through the documents that you've provided and provide that answer to you. So if you've got a bunch of medical documents that you've ingested into Amazon Kendra, you ask of it how much paracetamol should an adult have per day. It can potentially search through that document and provide you the specific answer based on the documents that you've provided it. Amazon Lex. So if you've ever used Amazon Alexa, the conversational engine that Amazon Alexa is based on is provided here as a service that allows you to build conversational engines that use either voice or text, and you can integrate that within your application, whether that's mobile-based or web-based. You can even put Amazon Lex on the end of a phone call, so you can potentially converse using the human voice over a phone call with the Amazon Lex chatbot. And then finally, before we move on to SageMaker, I wanted to briefly mention CodeWhisperer as well. So this is a Gen AI capability, generative AI capability for programming. If you are looking at doing some development over the hackathon weekend, you can integrate CodeWhisperer within your favorite IDE. Mine is Visual Studio Code. I integrate it with Visual Studio Code. The languages it supports are Python, Java, and JavaScript. And it will be able to provide you sample code or snippets of code based on what you ask of it. So if you needed code to be able to upload a file to S3, you can request that from CodeWhisperer, and it will provide that sample code to you. It's effectively like a pair programming buddy. It also does provide code that may not be AWS specific. So maybe you need to connect to a WebSocket and pull information from that WebSocket in JavaScript. You can request that from CodeWhisperer, and it will provide that sample code to you. All right, Amazon SageMaker. So This is effectively an umbrella service offering that provides a number of different capabilities, but specifically to build, train, and deploy machine learning models. It provides the end-to-end journey. So everything from being able to prepare the data that you're potentially going to be using to train your model. It provides a lot of the infrastructure that you may require, such as hosted Jupyter notebooks. It can potentially provide you out-of-the-box machine learning models that you can deploy straight away or that you can fine-tune with your own data. It provides a training environment for you to be able to quickly spin up training jobs, be able to train a model. It provides the deployment and management of that machine learning model as well to ensure that you're able to deploy it in a highly available manner so that it can be, inference can be requested of it. So just starting with some of the capabilities that Amazon SageMaker provides, and specifically the capabilities that are probably more towards the no-code end. Amazon SageMaker Canvas provides an environment for those that may not be as familiar with machine learning to be able to utilize, to be able to generate machine learning predictions. So with SageMaker Canvas, you can provide it your data set, and it effectively uses AutoML to generate predictions. So if you've got a data set of sales within a organization, and you want to predict the demand of those sales over a period of time, you can specify a specific column and say, I want to understand what this column might look like in 2 months. And AutoML will work that out for you. It will determine what model to use, what algorithm to use, and train it appropriately. Amazon SageMaker Studio provides effectively an integrated development environment that allows you to do everything from prepping data to training models and managing and monitoring models that are deployed. It is, if you've used Jupyter Lab, it looks very similar to Jupyter Lab with a number of additional capabilities, but it is effectively the integrated development environment that allows you to do everything that you need to build and train a machine learning model. It provides the ability to build machine learning models, so it provides Jupyter notebooks out of the box. It has a number of built-in algorithms that you can use in pre-built container images, and I'll show you what that looks like when we actually kick off a training job, what happens under the hood. It also provides pre-built solutions in open source models. So there's over 150 popular open source models that you can deploy out of the box and get started straight away. You don't necessarily need to build and to train your own model. And there's support for major frameworks and toolkits as well. So if you've got your own algorithm that you want to use with a framework like TensorFlow, that's easy enough to do in SageMaker as well. So if you do want to deploy an out-of-the-box model, a lot of our foundational models, so a lot of our generative AI models that are open source or they're proprietary models are available via SageMaker Jumpstart. So these give you a bit of an idea of some of the capabilities that are available. We've got models available from Stability AI, for instance. Most of us may be familiar with Stable Diffusion, where we can do text to image. I like to use it to put my dog in a suit. So, you know, there's lots of business cases that are probably more relevant. But then there's also large language models that we're all familiar with as well. So you can deploy these out of the box and get started straight away. So when you are looking, oh God, it looks like my PowerPoint has crashed again. Just my luck. I will launch it again. Apologies for that.
No problem at all, Bobby.
It's I'm not sure what's going on here tonight, but scroll back to where I was. There we go.
We don't have much questions either.
Okay. Cool. Okay. So hopefully you can see that.
Perfect. Yes, we can see that.
Cool. So if you did want to deploy a foundational model and get started, so if you want to get started with Gen AI on AWS, it's quite easy to get started. So in SageMaker Studio, you can navigate to Jumpstart. You can choose a foundational model offered by one of the model providers. You can then click to deploy, and for some of the models like Stable Diffusion 2.1, you can fine tune that model with your own data set as well to make it more applicable to your use case. As I mentioned before, SageMaker does have a number of built-in algorithms, or you can build your own. So, most of the popular use cases are dictated here. When we're talking about built-in algorithms or bringing your own, it's worth getting an understanding of how things work under the hood. So generally, when we're training on Amazon SageMaker, it might be slightly different to what you may do outside the cloud. So I know, if I was ever to kick off a training job on my local machine, usually I'm running a Jupyter notebook on that local machine. I've got GPUs on that local machine. I've got my training data on that local machine. Whereas with the cloud, generally you want to, you definitely want to optimize how you're using those instances that have GPUs. So you probably don't want GPUs sitting there idle as you're writing an algorithm or as you're transforming your data into the appropriate format before kicking off the training job. So as a result, what you usually do is provision a Jupyter notebook on a much smaller instance to be able to write your algorithm or to be able to transform your data. Once you've got that ready and into place, you then create a training job via the Amazon SageMaker control plane. That will then provision the relevant or the required resources, the compute resources, that will then pull in the container, the deep learning container that has the relevant frameworks. So maybe that's a TensorFlow container, for instance, container image that it will run. It will also pull in your training data from potentially Amazon S3. It will train the model. It will push the model out to S3, Amazon S3, and then it will shut down all of that compute. So effectively, you're only using the compute for the period of time that you're running the training, which is really optimizing on cost. You want to really just only have GPU instances running when you're running training jobs. You want to ensure that they're shut down and not consuming resources. Therefore, you're not paying for them if they're just sitting there idle. When we're looking at deploying a SageMaker, a model that was built in SageMaker, we're usually looking at deploying them on the back end in multiple availability zones, so effectively in a highly available fashion, and is fronted by a load balancer that's able to be able to request inference from them. On the right-hand side, someone may be accessing maybe a web front end that requests that would request inference. A Lambda function then requests that with input data, and it provides a prediction response, usually in the form of JSON, which it can then interpret and provide information back to that client. And then finally, this is my last slide before we move to Q&A. Feel free to ask me any questions that you may have. The last slide that I have is on RStudio. So if you are looking at doing statistical work, you can certainly provision RStudio on SageMaker as well, which is a managed or cloud-based RStudio IDE or integrated development environment, allowing you to leverage the RStudio that you may already be familiar with, but in the cloud. So with that, are there any questions?
Thank you so much, Bobby. There was the same question, like how do participants can get the AWS credits? Do you want to go through it? Perfect.
Yep, definitely. So I will be jumping onto the GovHack Slack workspace after this session. I will have credits available. So if this is something, if you're interested in getting started with AWS, feel free to message me on the GovHack channel. You can find me under Bobby Kubor. Message me on there. I will be able to provision you some credits and you'll be able to get started.
Perfect. Thank you so much, Bobby. If the participants could not find Bobby, please reach out to our volunteers, mentors, or even the board people. So they're going to be happy to help you out. Since we don't have any questions, I made some notes of questions.
Uh-oh.
So, simple ones for sure for you. Oh, I think.
There we go. Yes, that's a good question, actually. So will you be around on the weekend also for the credits or just today or tonight? I'll be around all weekend. I'll be bringing my own little projects that I need to be working on. So I'll be making the most of being in the Canberra office. So definitely you'll be able to see me hanging around the office. If you need credits to be able to build something, sometimes people underestimate or accidentally leave something running. Feel free to come find me in the office. I'll be able to hook you up with credits.
Perfect. Thank you so much, Bobby. My quick question is, are there any pre-trained AI models that are available that we can fine-tune it and adapt for our hackathon problems? Is there any suggestions?
There is, however, I can't remember the one. The only one that I remember off the top of my head is Stable Diffusion 2.1, mainly because that's the one that I like to play with because I like just creating silly images. Because like you can sort of put your dog in a tuxedo or whatever. I love Stable Diffusion, some of the stuff that you can do with it. So I know Stable Diffusion 2.1 allows you to point at your data set to be able to customize it and fine tune it. There are other models as well that you can use, foundational models. I would assume there's probably some large language models that you could probably fine tune, but admittedly, I don't know off the top of my head. I'd have to take a look and get back to you. But certainly there is the option for some of the models to be able to fine tune them.
Perfect. Thank you so much, Bobby. No problem at all. I think you can ping us some information during the hackathon as well.
Yeah.
Oh, I'm just looking at the time and I've got a couple of more questions, but I would say that I know that Bobby has been tired running 2 sessions. I'm not going to put any more pressure on Bobby.
My brain is mush.
I'm not going to pressure you anymore. Thank you so much, Bobby. We really appreciate your time at GovHack and the contribution that AWS does for GovHack each and every year. I think we're growing stronger and stronger each year. That's so good to see. Thank you so much, Bobby. Before we jump off, can I request Jason to bring on this event? Perfect. Thank you so much, Jason. Our next and final event is the hackathon event itself, which means that we don't have any other events coming in between. Get prepared for the hackathons. I'm just going to reiterate that Friday, the 18th of August, 5:30 to 6 p.m. around, the physical venues opens at your local time. Make sure it's in your local time. And all the challenges will be announced at 7 p.m. your local time. And make sure that you're on Slack, ask for people, make sure that you form a team quickly now. And 17th night at 7 p.m. AEST, I will be running a trivia event. So it will be more fun. You will be tired from the Friday and the Saturday pressure of doing your finding the solution. So you can come in and enjoy the trivia event as well. Make sure that you are on track with all the events and make sure that you follow the time and be in touch with us in Slack. Cool. And this concludes our today's AWS event. Thanks everyone for joining. See you all on the Friday opening event.